Today we're going to be talking about the Pythagorean Theorem. Okay, and so our learning target is I can use the Pythagorean Theorem and its converse to solve real-world problems. Okay, so let's talk about what the Pythagorean Theorem is. Pythagorean Theorem is basically a formula. Let's go ahead and put that it's a formula. And it helps us to find the missing side lengths of a right triangle. Okay, it's only for a right triangle. Okay, so you're only going to use the Pythagorean theorem on right triangles. Remember, a right triangle looks like this. Looks like this. It's a right triangle, and then it has a 90 degrees because it's right. Okay, the legs always form a 90-degree angle. They are labeled A and B, and they will be the shortest sides of the triangle. So if we look at this triangle right here, let me make it a little bit bigger. Here's a 90-degree angle, right? This angle, or this side length here and this side length here, those are going to be the legs, and we're going to call those A and B. Those are the legs. And the hypotenuse is the longest side. Okay, let's go again. Okay, and so the longest side here, it says it lies across from the right triangle, so we're talking about this part right here, right? And it's labeled C, and the hypotenuse is always the longest side of the triangle. Okay. So we have A and B, which are the legs, and then the C, side length C, is going to be the hypotenuse. Okay. So the Pythagorean theorem is the sum of each leg squared, and it's equal to the hypotenuse squared. And so you might have heard this or seen this before. We have A squared plus B squared equals C squared. That is the formula of the Pythagorean theorem. So we're going to get what A is here, and we're going to square it. That's an exponent too. We're going to add B, which is this side length here, and we're going to square that. And with this theorem, they said that if you have A and B and they're squared and they're being added to each other, it's going to equal C, the hypotenuse, it's squared. Okay, this is the formula of the Pythagorean theorem. Let's go ahead and do some of these examples. So it says, will the side lengths of 6 centimeters, 8 centimeters, and 10 centimeters form a right triangle? Use the Pythagorean theorem to decide. So we have a triangle, right triangle, assuming it's a right triangle, right? The side lengths of 6, 8, and 10. Remember, the legs are always the shortest one. So I know 6 and 8 are going to be one of these two, okay? Let's go ahead and put them the other way so that way they look a little bit better. And then the longest side is always the hypotenuse. Okay, so I'm going to put the longest side is always across from the 90-degree angle. So we're going to put 10 there. Okay, and we're going to use the Pythagorean theorem to see if this is a right triangle. Okay, so first I'm going to get my A squared. Let's go ahead and call 8A, B is 6, and then C is 10. Okay, so I got A squared. Let's do 8 squared plus B squared, which is 6 squared. You could have done either way, like 6 squared plus 8 squared. And then C, the hypotenuse, that's the one you cannot change. It's always the longest side. Okay, so I'm going to put 10 squared there. Let's go ahead and simplify each of those squares. Okay, so here, if you put in the calculator, 8 squared is going to be 64. 6 squared is 36. And 100 squared is, 10 squared is 100. Okay, let's go ahead and simplify this part. And if this is a right triangle, then it should be 100 equals 100. Let's see. 64 plus 36 is going to give us 100. And we see here 100 is equal to 100. Right? So this triangle is a right triangle. So yes, it forms a right triangle. Okay, let's look at this one. The next one, it says, will the side lengths 5, 7, and 12 form a right triangle? We're going to do the same thing. Okay, we got a right triangle. Supposedly it's a right triangle. Side lengths of 5, 7, and 12. I know 12 is my hypotenuse, so it's always the longest side across from the 90-degree angle. Then we have 5 and 7, so I'm going to put 5 and 7 there. Okay, I'm going to go ahead and label them. A is going to be 7, B is going to be 5. Again, you can switch them. B can be 7 and A can be 5. The legs are always the smallest ones. And C, the hypotenuse, is always the longest side. Okay, let's go ahead and put this down. We got A squared, which is 7 squared, plus B squared, which is 5 squared, is equal to C squared, which is 12 squared. Okay, and I'm going to simplify 7 squared, 5 squared, and 12 squared individually. So 7 squared is going to be 49. We got that plus 5 squared is 25. And 12 squared is 144. Okay, now let's go ahead and simplify this part. We got 49 plus 25. We get 74. Yeah, oops, one thing. Okay, wait. 74 is not the same as 144, right? You're missing a lot of values. So this is not true. This does not equal each other. So that means that the Pythagorean theorem didn't work, and this triangle is not a right triangle. So our answer, this one is no, it does not form a right triangle. Okay, so do you see here, when it does equal each other, like here it was 100 equals 100, that's the same, so that's a true statement. So we can say that we use the Pythagorean theorem to prove that this is a right triangle. On the other one, they did not equal each other. So the statement was false. And so since the statement was false, this triangle is not a 90-degree a right triangle. Okay, so let's look at using the Pythagorean theorem to find a missing length. Okay, so here we have an example of, and we already have a right triangle. The base of the triangle is 3 inches and the height of the triangle is 4 inches. Find the length of the hypotenuse. So we know the hypotenuse is going to be the longest side over here, right? So here, let's see, we have the base is 3, so they said base is 3, and the height is 4. Okay, that means A equals 4 and B equals 3. That means C is our hypotenuse, right? So that's what we're looking for. I don't know what that is. I'm going to put a question mark there. Okay, so this is how I'm going to write my equation. I know my formula is A squared plus B squared equals C squared, right? So I'm going to put, for A squared, I'm going to put 4 squared plus B squared is going to be 3 squared is equal to C squared. Okay, I need to find out what C squared is, and this is how I'm going to do it. I'm going to simplify just like we did in the last one. 4 squared is going to give us 16, and 3 squared is going to give us 9. And then we still have that C squared because I don't know what that is, right? 9 plus 16, 16 plus 9 is 25. Okay, and then this is where something new happens. Right now we have that C squared is equal to 25. Not that C is 25, that's not the answer. Okay, C squared is 25. Okay, so to find what C is, you're going to take the square root. Okay, and you're going to do it on both sides. So just like we have like 3x is equal to 2. To get rid of the 3x, or to get rid of the 3, to get the x by itself, we would divide by 3, right? That's the opposite of multiplication. Well, the opposite of getting a square is a square root. So I'm going to take the square root of both sides. When that happens, I put in square root of 25 in the calculator. I get 5. And my c, the square root and the square, they cancel each other out, and you're left with just c. So c is going to be 5. Okay. You can put c is equal to 5 inches. Okay. If you wanted to check your answer, we can. We got 4 squared plus 3 squared equals 5 squared. That's what we said. I'm going to simplify all the squares. So that's 16 plus 9 is equal to 25. Okay. 16 plus 9 is 25 is equal to 25. Yes, it works out. I know this is a right triangle with the hypotenuse length of 5 inches.